These bar-tailed godwits, they breed up in Siberia. Taking a reference photograph of the tree with the nod. This is a native to the Capricorn Bunker, this southern end of the Great Barrier Reef. I'm Mike Bennett. I'm a professor, honorary professor at the University of Queensland. And I'm involved in the Leaf to Reef project, really looking at the birds and how they bring nutrients to the island. Well, we've got a tree here and it's full of black noddies or white-capped noddies, their other common name. And they basically nesting in here. When they decide to avoid their bowels, have a poo, it tends to fall on the ground. It doesn't get interrupted by the fact that there's leaves or anything like that in the way. So what we're going to do is put down a sheet of plastic or sheets of plastic and try and catch the poo. So we'll count it, we'll count the number of birds, and we'll eventually we'll dry it, and we'll know how much poo on average an individual bird will produce, and that multiplied by the number of birds of this species on the island, which is another part of the project, will give us a handle on how much nutrient is actually coming to the island. We've decided that we'll do it repeatedly for an hour at a time, so we have maybe half a dozen collection periods at different times of the day to see if there's any variation with the time of day. And also it just gives us replicates, so we're not just taking one value and hoping that that's robust. Taking a reference photograph of the tree with the nod. 7, 28, 30, 33?
What did you get?
33?
I got 35.
I'll recount them. We always have this, we can never agree on the counts because the birds come and go. And what we're looking for is little white pearls, as it were, in the sunlight. Glistening pearls of guano. Well, I guess you have to take a light-hearted view of some things. If you have a look at the nests themselves, they're covered in guano. And the tree is not usually white. A lot of the guano lands on the nest. So you'll notice that for most of them, there's just one bird on the nest. So they take it in turns to either sit on the egg or sort of sit with the chick while the other one goes fishing. Because what we really want to do is know how much a bird that goes out fishing at sea, how much it brings back and how much of that nutrient, and well, it's mostly nitrogen we're interested in, how much of that, there's a good one. You could hear that one go plop. Ooh, another one, you get that one?
Yeah.
There it is. Yep, that's a good one. We're going about 1 a minute. That's the 12:20. 10 minutes to go. Oh, that was a fabulous one. I think that was the biggest one of the session, reaching a crescendo.
5, 4, 3, 2, 1.
Okay, not even one on the siren. 54. Just do a reference photo, but that was 54. Productions from 35 probably on average birds in 1 hour. We found out from our studies that each bird produces guano or poops 1.5 times each hour. We know how many birds were pooping, and so we can work out how much that means in terms of dry mass per hour. And it turns out that it's 66 milligrams of guano or poop per hour per bird.
That's definitely more, and that's definitely more.
So we're going faster at the moment. Yeah. Four of them, and the fifth one just beyond the cone. Second part is we need to know how many birds are on the island. So by doing a detailed census, we can come up with a total estimated number of birds on the island. These bar-tailed godwits, They breed up in Siberia or in the tundra during the northern summer, and then they come all the way, they fly all the way down the eastern flyway, so basically along the coast, China, Japan, all the way down to Australia, and then they spend their summer, the southern summer, down here. So there's one there, you see it's got a slightly upturned bill, and it uses it usually to probe mud. So they like mud flats, but these are juveniles, and I guess this is a make-do habitat for the time being. So yeah, it's a journey of tens of thousands of kilometers, and they do it every year, coming here, feeding up, getting fat enough to breed, flying back. But the real problem with them, and a lot of other birds, or problems they're facing, is that a lot of the habitat, the coastal habitat along the flyway, is being modified. So different countries have developed prawn farms and other industries along the coast, or they've built out over mud flats, and a lot of their feeding grounds, which are like refueling stations, have just been obliterated. So some of the species numbers have crashed by about 95% above their original sort of naive population. So things aren't good for these long distance migrators. And there's a lot of effort around to try and reverse the situation. But yeah, it's good to see them here. At the edge of the runway, we have a number of paths that lead off into the woodland, and this one actually leads to an old well that they used to use for drinking water. This route provides access into the forest. So basically what I'm going to do is go in and look at the vegetation, estimate the height of the vegetation, and then see how many birds are in them, and try and work out why the birds, in the big scheme of things, why the birds are using those particular trees and not others. So what we can see on the left-hand side is that there's been a revegetation program, or a vegetation program, to try and suppress the weeds, and they've introduced a large number of this tree species, which is Pisonia grandis. This is a native to the Capricorn Bunker, this southern end of the Great Barrier Reef. And it's a woody herb. It'll grow, so it's a very lightweight wood, pretty soft. But these trees, in the right circumstances, will grow to maybe up to 20 meters tall. At this size, the tree doesn't seem to be appealing to them, and most of the trees are without any noddies whatsoever. And we'll see that they prefer other species of tree as we move in. The concern about Pisonia grandis is that it's a friend and a foe to the noddies. It can provide them with a nesting site, such as if we look just down here. We've got just a few noddies. Basically, there's one nest that's occupied in here, there's one there, another one, another one, another one. So there's a small number of noddies within these 3 or 4 trees. So it provides nesting habitat, but the flip side of the coin is this. These are going to be the flowers, and then the fruits. And the fruits, when they're mature, are black, and they're about a centimetre long, and they're covered in sticky fibres. And unfortunately, a lot of noddies, well, none of the noddies know what they are, and if they happen to brush past them, they can get these sticky seeds attached to their plumage, and in some circumstances it attaches the wing to the tail, and they basically can't fly, and they will fall off and nature takes its course. But the tree can potentially benefit from the nutrients of a decomposing bird's body, and also the sticky seeds allow the seeds to be transported to other islands, for example. So the tree is in a winning position, and the noddies perhaps not so much. This is a casuarina or casuarina, or a she oak, and these were planted on the island probably back in the 1950s. There was a big program of putting this tree on the island. Apparently it was never ever here, so it occurs on other islands within the Capricorn Bunker group. But Interestingly for the birds, the white-capped noddies that we can see in the tree, it is a preferred nesting habitat for them, whereas on all of the other Great Barrier Reef islands, they don't nest in casuarinas at all. So what I'd normally do, and will do now, is I've got a drone footage imagery of the whole island, and I just print out regions of the island of interest, and then I can identify individual trees on this printout. And this she oak here, this casuarina, sits just here off the edge of the runway, or the runway short vegetation. And then the laborious task of counting. So what do you do? Well, the way I've dealt with this is to count the active nests. So any nest that's got a bird sitting on it, whether there's an egg or not underneath, doesn't matter. Any nest with a chick, whether it's attended or not, counts as an active nest. So I count all the active nests. So we've got that one sitting on an egg, there's a chick in that one, and that one's sitting on an egg. Well, it's currently standing because it's so hot. So there are 3 active nests. And then you have to look through the whole tree, and I've got 3, 4, 5, 6, 7, 8, 9, 10. But it basically tells me there are 14 active nests, so there must be 24 birds. With the species of the tree, the height of the tree, the number of active nests, and also combining it with the other number, the number of birds that are actually visible at the time. And then repeat, 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 repeat. Let's take an estimate of 20,000 birds. That gives us 1.5 grams of poop per bird per day, times 20,000 birds on the island, which gives us 32 kilograms of nitrogen-rich fertilizer being deposited per day by the population of this species of bird on the island. And to put that into sort of an easier contextual space, if you think about going to Bunnings and getting a nitrogen-rich fertilizer for your garden, they're usually about 20 kilos. It's like having 1.5 bags of that fertilizer dumped on the island each day. So that's, for one species, the most numerous species, albeit, is delivering a large amount of this nitrogen-rich fertilizer to the island, goes into the vegetation, and some, and we have yet to work out how much, goes into the groundwater and then is distributed perhaps across the reef and has an effect there. So they're the main species that are involved in bringing nutrients derived mostly from fishes that are caught and digested, and then the nitrogen is dumped on the island for the benefit of this ecosystem.